This is sections 5.7 and 5.8 of Honors Algebra 2, complex fractions and fractional coefficients. So the first topic for today's lesson is complex fractions, and those are fractions inside of other fractions. So what we're going to be doing, our task, is to simplify those complex fractions, and here's how we do it. We simplify the numerator, we simplify the denominator, do those separately, and then we divide them. We divide that numerator and the denominator. So, best way to learn, by examples. Example number 1. Our task is to simplify x minus 1 over x all over 1 minus 1 over x. So we are going to work in the numerator first. We're going to simplify the numerator. What I mean by that is to get it all as one fraction. So right now it's x and then a 1 over x and they're subtracted. I'm going to be able to write that as one fraction. I'm going to think of the x as an x over 1. I can do the same thing in the denominator. Think of the 1 as a 1 over 1. Okay? Now in the numerator I've got two fractions that are subtracted. How do I subtract two fractions? Well, I need a common denominator. What's the common denominator between 1 and x? Well, it's x. So I'm going to think of x over 1 as the x squared over x. I'm going to multiply the numerator and the denominator both by x. And I've got minus 1 over x. Okay? And then in the bottom, 1 over 1 is the same as x over x. That way I've got two fractions with the same denominator. Okay, so we simplify in the numerator. I'll have x squared minus 1 divided by x. And then in the bottom, I'll have x minus 1 divided by x. Okay, so now I've simplified the numerator, which is x squared minus 1 over x. And I simplified the denominator, which is x minus 1 over x. And now I need to divide them. Well, dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to rewrite this as x squared minus 1 over x times x over x minus 1. I'm going to flip the bottom fraction and multiply by that. Multiply by the reciprocal. Okay? X squared minus 1 factors as x minus 1 times x plus 1. And that's over x times x over x minus 1. So what common factors can I cancel? Well, I've got an x on the top and the bottom. I can cancel those. I've got an x minus 1 on the top and on the bottom, and I can cancel those. What does that leave me with? X plus 1 over 1, which is just x plus 1. So that whole thing we started with simplifies to just x plus 1. So that's sort of the process of complex fractions. We're going to simplify the numerator, simplify the denominator, then convert it to multiplication by a reciprocal, and simplify from there. Number 2. A to the negative 1 power minus x to the negative 1 power, all divided by a to the negative 2 power minus x to the negative 2 power. So let's get rid of these negative exponents by writing it as 1 over a minus 1 over x all over 1 over a squared minus 1 over x squared. And now let's work in the numerator and denominator separately. Combine them into one fraction, so I'm going to get a common denominator of a over x, or of a times x, I mean. So that'll be x over ax minus a over ax, all divided by x squared over a squared x squared minus a squared over a squared x squared. So in the numerator I've got x minus a over ax. That's my new numerator. In the denominator I'll have x squared minus a squared over a squared x squared, and that's my new denominator. I'm dividing by that denominator. That's the same as multiplying by the reciprocal. I've got x minus a over ax times a squared x squared over x squared minus a squared. Okay, let's factor that x squared minus a squared. That is a difference of squares. X minus a times x plus a. So I can cancel the x minus a's. I can cancel the a on the bottom with one of them on the top, and the x on the bottom with one of them on the top. What am I left with? Well, there's still an a and an x on the top. And on the bottom, there's just an x plus a. Number 3. 1 over x plus 1 over x plus 1, all divided by 1 minus x or 1 over x minus 1 over x plus 1. Again, we'll rewrite the numerator and the denominator each as one fraction, and then we will multiply by the reciprocal. So, my common denominator in the numerator here is going to be x times x plus 1. So I need to write this as x plus 1 over x times x plus 1. That's what the 1 over x becomes, plus x over x times x plus 1. That's what the 1 over x plus 1 becomes. Alright, simplifying my denominator. Again, the common denominator will be x times x plus 1. So that's going to be x plus 1 over x times x plus 1 minus x over x times x plus 1. Can I just cancel out the x plus 1 over x times x minus x plus 1 because it's on the top and the bottom? No, because on the top it's added, on the bottom it's subtracted. I can only cancel things that are multiplied into the top and the bottom. That's why I need to keep simplifying. So I've got x plus 1 plus x over x times x plus 1 all over x plus 1 minus x over x times x plus 1. Keep simplifying. X plus x is 2x, then a plus 1 over x times x plus 1. I'm going to leave it in factored form like that so that I can maybe cancel common factors. And then x minus x is 0, and I just got a 1 down there, over x times x plus 1. Okay, multiplying, or dividing by a fraction is the same as multiplying by the reciprocal. So 2x plus 1 over x times x plus 1 times x times x plus 1 over 1. That's what I have now. I can cancel an x. I can cancel x plus 1. That leaves me with 2x plus 1 over 1, but dividing by 1 doesn't change it, so it's just 2x plus 1. Alright, now we're going to solve equations that have fractional coefficients and inequalities that have fractional coefficients. And these are super easy, because all it involves is multiplying everything by the common denominator to get an equation that does not have fractional exponents. Fractional coefficients, I mean. So, I look at my denominators. They're 2, 15, and 10. What's the least common denominator? What's the least common multiple of 2, 15, and 10? 30. So I'm going to multiply everything on both sides by 30. So I'll have 15x squared equals 15 will go into the 30 two times. 2 times 2x is 4x. And then the 10 goes into 30 three times. 3 times 1 is 3, so plus 3. And now I can get everything on one side and set it equal to 0 on the other side, and it's a quadratic equation that I can factor. Hey. So how do I factor that? I take 15 times negative 3, that's negative 45. 5 factors of negative 45 that add together to be negative 4. That may be negative 9 and positive 5. I can't divide either one of those by 15, but I can divide negative 9 by 3 and 5 by 5. That'll give me negative 3 and positive 1. So when I factor it, as I divided by 3 and 5, I'll have 3x and 5x. The number I got when I divided by 3 was negative 3, so that goes over here. The number I got when I divided by 5 was 1, so that goes over here. So it factors as 3x plus 1 times 5x minus 3. So that means 3x plus 1 equals 0, or 5x minus 3 equals 0. So 3x equals negative 1, x equals negative 1/3, or 5x equals 3, and x equals 3/5. My solution set then, negative 1/3, comma 3/5. Number 5. Same thing, but an inequality. So we're still going to multiply by the common denominator. What's the common denominator of 8, 3, and 6, about 24. So we're going to multiply everything on both sides of my inequality by 24. Okay, when I multiply x over 8 by 24, the 8 goes into the 24 3 times, so I have 3x. When I multiply x minus 2 over 3 times 24, the 3 goes into the 24 8 times, so I'll have minus 8 times x minus 2. That is greater than or equal to, when I multiply x plus 1 over 6 times 24, the 6 goes into the 24 4 times, leaving me with 4 times x plus 1, minus the 1 times 24 is 24. Now this is an ordinary linear inequality that we can solve. So that's 3x minus 8x plus 16 is greater than or equal to 4x plus 4 minus 24. 3x minus 8x is negative 5x plus 16 is greater than or equal to 4x minus 20. I subtract 4x from both sides, it gives me negative 9x. I subtract 16 to the other side, that'll give me negative 36. So negative 9x is greater than or equal to negative 36. So divide both sides by negative 9. And x is less than or equal to 4. Why did I change the sign? Because I divided by a negative number. So x is less than or equal to 4. So my solution set is the set of all x, such that x is less than or equal to 4. And of course, we could graph that on a number line if we wanted to. So these equations and inequalities are really no different from what we've done before. We just multiply everything by the common denominator first, and then we can solve them. So let's try one as a word problem. Crane A can unload a container ship in 10 hours, and Crane B can unload it in 14 hours. Crane A started to unload the ship at noon and was joined by Crane B at 2 p.m., so 2 hours later. At what time was the unloading job of the ship completed? So let's perform 4 steps of this problem-solving process. Number 1, we're going to define a variable, and we only need one here. If we're interested in what time the unloading job of the ship will be completed, we want to know how much time it takes from when it started. It's starting with Crane A. So let's let t be the number of hours Crane A has worked. Okay? If that's the case, how many hours has Crane B worked? Well, 2 less than A, so t minus 2 would be the number of hours Crane B has worked. Okay. So now we're going to organize our information. That's step number 2, and I'm going to do it in the form of this table. So in 1 hour, how much can Crane A do? Well, it can do a whole ship in 10 hours. So in 1 hour, it must be able to do 1/10 of a ship. Okay? This is a crane, so it's not like wearing out over time where it's going to be able to be more productive at the beginning and less productive later. It's a machine, so we're going to assume its rate of productivity is constant. So if it can do the whole ship in 10 hours, it can do 1/10 of the ship in 1 hour. So that means in t hours, it can do t times 1/10, or t over 10. That's how much it can accomplish in t hours. We don't know what t is, we don't know how many hours it's working, but whatever it is, it's done t over 10 amount of the ship. Crane B, if it takes 14 hours to do the whole ship, it can do 1/14 in 1 hour. Now how many hours is Crane B working? Well, it's working t minus 2 hours. So it can do t minus 2 times 1/14, or t minus 2 over 14. So the t over 10 is telling us the part done by Crane A. And the t minus 2 over 14 is telling us the part done by Crane B. That's the portion of the ship. That's what I mean by the part. The portion of the ship done by Crane A, the portion of the ship done by Crane B. Together, they're doing the whole ship, right? So if I go over 10 and add to it t minus 2 over 14, I should get a whole ship. I should get one whole ship. So that's my equation. The fraction done by crane A plus the fraction done by crane B must equal a fraction equivalent to 1. It must be the whole ship. So step 3, I'm going to solve my equation. Alright, well, what if I multiply everything by the common denominator? What's that common denominator? We can multiply everything by 140, but turns out 70 works as well. Well, 10 and 14 go into 70, so I'm going to multiply everything by 70, including the t over 10, the t minus 2 over 14, and the 1. So when I multiply t over 10 by 70, I get 7t plus 14 goes into 70 how many times? 5 times. So 5 times t minus 2. And 1 times 70 is 70. Okay, so I've got 7t plus 5t minus 10 equals 70. And I take the 7t plus 5t, I've got 12t equals 80. So t equals 80 over 12, which simplifies to 20 over 3, which is 6 2/3 hours, which is 6 hours and 1/3 of an hour is 20 minutes, so 2/3 is 40 minutes. 6 hours, 40 minutes. So, step number 4 is to answer the question, at what time was the unloading job of the ship completed? So if it took 6 hours and 40 minutes, then, and we started at noon, then what time is it done? Well, it should be done at 6:40 p.m. And here are your immediate practice problems. 3 problems. Simplify the first 2, solve the third one. The first 2 are just expressions of complex fractions that you're going to simplify. The third one is an inequality you're going to solve. That is the end of sections 5.7 and 5.8.